In this chapter, we're going to look at systems of equations. In this lesson, we're going to solve word problems using systems of equations.
Okay, hi everybody. So now we're going to take a look at word problems related to systems of equations. Okay, so we're just going to look at a handful of word problems here, but I'm going to try to show you kind of step by step the sorts of things that, well, for example, if I was your teacher, what I would be looking for specifically, okay? So let's take a quick look at it. And the question says, use either elimination or substitution to solve the following. Okay, so tickets are sold for the Senior Safari Day at the Greater Vancouver Zoo. Merrill buys 5 admission tickets and 3 train tickets and pays $65. Howard buys 2 admission tickets and 1 train ticket and pays $25. Create a system of equations to determine the price of each type of ticket. Okay, so I know that for a lot of people, word problems are just like the bane of their existence. I get it, okay? So let me try to lead you through this as simply as I can here. The very first thing that I want you to do is I'm going to let you create, or I want you to create a let statement. And so what I mean by that is I want you to identify what your variables are going to be. Now, what is it that you're looking for? Well, the final sentence here says create a system of equations to determine the price of each type of ticket. Now, we're not actually being told to solve the system, but I'm going to do it anyway. Okay, I just can't help myself. I'm just going to do it anyway. So we want to determine the price of each type of ticket. So maybe what we do here is let's take a look at the 2 types of tickets. We've got admission tickets and train tickets. So I'm going to let A equal. Now, and it says the price of each ticket. So it's not the amount of admission tickets. It's the price of the admission tickets. And you need to be clear on that. When I have people say A is the admission ticket, well, what about it? Is it the ticket itself? Is it the number of admission tickets? In this case, it's the price of the admission ticket. Okay, that's specifically what I want A to be here. And then I'm going to introduce another one. I'm going to let T be the price of the train ticket. Now, if I was marking this, okay, if someone who handed this in, I would give a mark for that. Because what I've seen here, when people don't do this, when people don't identify it and then just let their variables go in there, I've watched students at the end there, when I then ask, okay, well, what are the prices of the tickets? And they quite honestly, even though the right work is down there, they don't even know which one is which. They're not clear. They just kind of jumped into it, did the math, but at no point did they actually set themselves up to communicate the answer correctly. So this is part of mathematical communication, being very clear right off the bat what my variables are, so that as I work through it, when I get to the answer, I can intelligently turn around and say, this is what my answer is. So that's the very first thing I want you to do. The second thing we're going to do here is we're going to create equations. This is probably the hardest part of any kind of a word problem is coming up with the math interpretation of the English here. But usually, this is not always the case, but usually sentences become equations. So for example, Merrill buys 5 admission tickets and 3 train tickets. Okay, I'm not even going to finish the end of that there. She buys 5 admission tickets. Okay, so that's 5 A's, and I know that that's a multiplication when I say that. Okay, 5 A's, and that's addition, 3 train tickets, so 3 T's, and pays $65. So 5 admission tickets and 3 train tickets become $65. There's my first equation. My second equation comes from the next sentence here. Howard buys 2 admission tickets. Okay, well that's 2 admission tickets and a train ticket. So plus just 1 train ticket and pays $25. So the result there is $25. Okay, good. There's my system of equations. Okay. Now I'm going to do the algebra. And usually at this point in time here, once you've got a good starting point, the rest of this actually kind of falls into place. So the third thing I'd be looking for here is the work to solve that. Okay? And so now, well, look at this. I would be very tempted to do a substitution here. Okay? So I'd be very tempted to take this one down and say, okay, I know that based on equation 2, the second one here, that T would equal to negative 2a plus 25. I'm just going to bring the 2a over. So now from that second equation, I have an expression for t. In this system of equations, okay, I should be able to substitute that into the first equation. So I'm taking the second equation, plugging it into the t value for the in the first equation. So that's going to look like this. It's going to be in the first equation. This is going to be 5a's plus 3t's. But this time I'm going to use the expression from the second equation to replace that t. So negative 2a plus 25 equals 65. Okay, now I've got an equation that only has one variable in it. So I should be able to solve that. So 5a, distribute the 3 through, so negative 6a plus 75 is equal to 65. Okay, well, now I got to get my variables and my constants all kind of separated here. So I got 5a minus 6a, that's going to be negative a. And then I'm going to move that 75 over, so I'm going to subtract it and I'll get negative 10. And so I know that a is equal to 10. Wonderful. I've got my a. Now, because I've got a, and because I used substitution here, I can take that a value and go back over here and do a very quick calculation. Negative 2 times a, okay, is going to be negative 20, because a is 10, so negative 2 times 10 is negative 20, plus 25 is going to be 5, so my t value is going to be 5. Now, I just used this equation right here, this version of it, to get my final answer. So I'm just going to do a quick check. I'm not going to write it out, okay? I'm not going to do that, but I am going to check it here. 10 and 5 here. So 5 times 10 is 50. 3 times 5 is 15. 50 and 15 is in fact 65. So I feel very good that I got the right answer here. And so now the final part of this word problem that I need you to go through is I need you to now interpret the result. Okay? So these first two steps here are about interpreting the word problem. Okay, this is about communication. Step 3 is the math here. Okay, is the actual process of figuring out what's going on here. But step 4 is another communication thing. So what's happened here is I've in these first two steps, I've gone from the word problem to the math. Do the math, and now I'm going to go back and communicate my answer here. So really, almost 3/4 of the work that I want you to do here is about communication. So let's answer the question. Create a system case to determine the price of each ticket. Okay, well, the admission tickets, the admission tickets are $10 each, and the train tickets are $5 each. Okay, and I know that because I know exactly what my variables mean, because I set myself up for success right away in this question here. Now, you're going to have to determine whether or not your teacher wants you to write out your answer in a complete sentence, or whether point form is good enough here, or whatever. But I do suspect that your teachers are going to want to have some sort of communication piece at the end there. Okay, let's take a look at the next one. It says a math test has short answer questions and word problems. A short answer question is worth 2 marks, and a word problem is worth 4 marks. Okay, so I mean, even at this point right here, I've given you what they're worth, so I suspect I know where this is going. What I didn't tell you is how many there were, so I suspect that's what we're going to be asked for here. There are 11 questions for a total of 30 marks. How many of each, and there they are, how many of each type of question are there? Okay, so the very first thing I want to do here is give my let statement. And so what have we got? We've got short answer and word problem. So we'll let S be the number, okay, of short answer questions. Now remember, don't get so lazy that you just write S equals short answer questions, because that doesn't communicate what you mean. S has to take on a value, and short answer questions isn't a value. Like what part of that are you implying there? And so we're going to let W equal the number of word problems. Now, in this particular case here, it turns out that when we get to step 2 here, where we're writing out the system of equations, it's not quite the same as it was in the previous one here. Sentences don't exactly translate over. So they're just showing an example of this. What do we read here? A short answer question is worth 2 marks, and a word problem is worth 4 marks. There are 11 questions for a total of 30 marks. Okay, so that mark total is over here. So what's going to happen here is I'm going to come up with two equations here, but my equations are going to deal with two different things here. First of all, if I take S and add W, okay, S is the number of short answer questions, W is the number of word problems. So when I add those together, that's going to be the total number of questions, in which case that's going to be 11. We were just told that. If I wanted to figure out the total marks, which I know is going to be 30, then I just have to figure out how many marks I'm getting for the short answer. Well, that's going to be 2 times S. And then for each word problem, I'm going to get 4 marks. And when you add those together, the answer here should be 30 marks. So S plus W should equal 11. 2S plus 4W is equal to 30. Now, one way that you can tell that you've done the equations right here is if you just run through it and think units, if I can kind of say it that way. This is number plus number equals total number. But down here, this is marks plus marks equals total marks. If you put the 30 up here, then you've got number of questions plus number of questions equals 30 marks. Well, that doesn't make any sense. Okay, adding up the number of questions. Okay, doesn't if you've got, let's say, 3 written response questions on your exam, that doesn't mean that's 3 marks, unless they're each worth only 1 mark. But that's not a direct connection here. Okay, so you got to be careful with that. So now the next thing I'm going to do here is I'm actually going to do the math. So I have 2 steps of communication where I'm interpreting the problem. Now I'm going to go through and solve the problem. And this time, you know what? Let's use elimination here. Let's get rid of the S's. Okay, I'm going to multiply the first equation through by 2. So that's going to get me 2S plus 2W is equal to 22. And then the second equation is 2S plus 4W equals 30. I don't have to do anything there. And then what I'll do to get rid of the terms of the S in it, I'm going to subtract the second equation. So 2S minus 2S is 0. 2W minus 4W will be negative 2W. Don't forget the negative. That's significant. That's important. 22 minus 30 is going to be negative 8. And then when I divide, I'm going to get that W is equal to 4. Okay? So that was nice. That was straightforward there. W equals 4. And then from there, I can do a quick substitution into here. And actually, in this case, it works out really easily here. If I plug 4 into my first equation and subtract, I'm going to get that there are 7 short answer questions. Okay? So now, all I've got to do, and I can double check that over here. So if I go, sorry, and that's what I was going to do here. 2 times S, 2 times 7 is 14. 4 times 4 is 16. When you add those together, you get 30. So now for my final step here, I'm just going to interpret it. There are 7 short answer questions and 4 written. There you go. Okay, so with this question here, we read that Annika's class raised $800 by selling $5 and $10 movie gift cards. Okay, now even right there, I can kind of anticipate that the question is going to be asking for the number of each kind, but let's keep going here. The class sold a total, okay, so that suggests an equation there, of 115 gift cards. How many, and there it is, of each type of card did the class sell? Okay, so we're going to start with our let. Okay, and I tell you what, because there's really no reason to pick one letter over another here, let's go back to our favorites here. Let's let X be the number of $5 cards, and we'll let Y equal the number of $10 cards. Okay, so there's our the first step right there. So now our second step is going to be to create the equations out of this that I need. So I've got a total, a money total here, and I've got a number total here. Let's start with this one right here, okay? So if X and Y are the number of each of the different types of cards, then adding them together is going to get me the total number of cards, so 115. Now likewise, I can look at money here. So how much money did I make on the $5 cards? Well, that's going to be $5 times however many I sold. Plus, in this case here, if I want to know how much money I brought in from here, I would say $10 times the number that I sold. Add those together should equal the total the total amount of money that I brought in. So here we go. So here are the first two parts. Again, I know I've said it before, but here are the two parts of the communication aspect of this problem. Now we're going to move on to the solution part. And by the way, you don't need to write the 1, 2, 3 like I've been doing here. This is just to kind of give you a procedure, give you an idea of what I'm doing. In this case right here, man, it would be very easy to do substitution or elimination. I tell you what, I did elimination last time. I'll do substitution now. So let's take that first equation. Let's solve for x. I know a lot of people like to solve for y. Let's solve for x just for fun here. So we're going to make that negative y plus 115. So from my first equation, I know that that is what I can replace x with. And I can do that into the second equation, doing the substitution. So when it says 5 times x, I know that I can make that 5 times negative y plus 115, and then plus 10y equals 800. Okay? Now I'm going to distribute, so it'll be negative 5y plus, okay, well 115 times 5, think about that, it's going to be 500, and then 5 times 15 will be 75, so it'll be 575 plus 10y is equal to 800. All right, well, putting together the y terms here, I'm going to get 5y, okay, negative 5 plus 10 will be 5y, and then if I go, what is that? That's going to be 800, and I'm going to subtract 575 from that. Okay, that will get me, oh no, I wanted to do that 100 over here. That's going to be 225. Okay, and now the last thing I'm going to do is divide by 5 to bring that over, and I'll get that y is equal to 45. Yeah, good. Now, if y is equal to 45, well, I can go back up to here, and I can easily plug that in to that expression that I have for x to figure out what y is. I can easily plug this into the expression for x to figure out what that x is. And that's going to be x is equal to 70. Okay, it's just going to be negative 45 plus 115. And so now our final step here will be to interpret what I've got. Okay, the class sold. What did we sell here? We sold 70 $5 cards and 45 $10 cards. Okay, so in this next question, what do we read? We read that a community group purchased 72 cedar tree and spruce tree seedlings to plant for an Earth Day project. Okay, right there, this is a total. Okay, it's the total of those two together. So there's a formula right there, an equation right there. And I suspect, even without reading this question even further, that what they're going to ask for is the number of each one of those. Now the next sentence says here that the number of cedar trees was twice the number of spruce trees. Okay, now there's an equation right there, and that word was. Okay, when I see it in a sentence like that, I know that state of being verb is going to mean an equal sign. Always does, okay? Is, was, are. It's almost always, I should say, an equal sign implied in that sentence there. It says, how many of each type of tree seedling did the group purchase? Okay, so number one, we are going to now we got a couple of nice variables kind of popping out of this. We're going to let C be the number of cedar seedlings. We'll let S be the number of spruce seedlings. Good. So now people can follow along the work that I'm doing. So when I move on to step 2, which is going to be to come up with the equations, people will follow along here. Now, I know that 72 is a total. A total of what? Well, it's a total of the number of cedar and spruce seedlings sold here. So that's going to be C plus S is going to equal 72. Now this other one here, this other sentence here where I'm getting this next equation, I should just have to read this here. The number of cedar trees was, okay, so cedar trees was, it's going to be C equals twice the number of spruce trees. Okay, well that's going to be 2S, twice the number. Okay, so now when I move on to step 3, because I've done the communication, I've done the interpretation, I've got the variables out of there, I've got the equations out of there. Now I got to choose a method to solve this, and I mean this one sets it up beautifully for substitution. Okay, because that second sentence there gave me an equation that was solved for one of those variables. So I'm just going to substitute in that 2s for c in the first equation. So right here, I will make this 2s plus s is equal to 72. Okay, and that's really straightforward there. I love the fact that happened like that. So on the left-hand side here, I know that it's going to be 3s is equal to 72. And then by quick division, I'll get that s is equal to 24. Yeah. So now if s is 24, and I know that c is equal to 2 times s, I know that c has got to be equal to 48. Now, I can do a quick check here just to see if I got that right. Let's see if when I add those together, do I get 72? Well, 4 and 8 is 12. And then that's going to be 1 and 2 and 4. That's going to be 7. So it's going to be 72. So that works here. So now I'm ready to interpret my results. Okay, so they bought, what did they buy? They bought 48 cedar seedlings and 24 spruce seedlings. Oops, I'm off the screen there. Okay, now this next question looks to be an investment question, and I know that some of you are going to have to give it just a little bit more thought as you build the equations here, okay? So what do we got here? We got Nuri invested $2,000, part at an annual interest rate of 8% and the rest at an annual interest rate of 10%. Now, without knowing much more about this, as soon as I say part, I know that I'm splitting that 2,000 up into two amounts here, okay? So there's an equation right there. I've got two different amounts that I know are going to add up to 2,000. So this is a total. So there's an equation being applied there. Now, after 1 year, the total interest, okay, now here's another total. I'm talking about the interest. And I get that by doing my percentage calculations. So how much money did Nuri invest at each rate? So what I'm asking for to start off with here, and again, in this situation right here, I don't really have a nice reason to use one variable over another. So let's just go back to x and y. So I'm going to let x equal the amount invested at 8%. And we'll let y equal the amount invested at, what was it, 10%, right? Yeah, there it is, 10%. Okay, good. So now I'm going to interpret equations out of this. Now I was just talking about that 2,000 is a total. Okay, I break it up into two amounts going into two different accounts here. So I know that x plus y is equal to 2,000. Now oddly enough, in an equation like this, I've seen this enough to know that as soon as people read the next sentence here, they tend to focus on the interest part of this. Okay. And the way the interest part here works, well, it requires that percentage calculation, and people get so focused on that oftentimes I'll see them forget to put this one down, this x plus y equals 2,000. Because most of the time, as soon as they're reading that, they're realizing, okay, 8% of this investment, so 0.08 times x plus 0.10 times y. When I put those together, my total interest is $190. There's my next equation right there. Okay, so those are my two equations. I hope they make sense. Like I said, a lot of times people focus so much on getting this one, and they get it, but they just forget about this one, the first one. So now, what I'm going to do is, because the last couple I did were both, I did substitution, I'm going to do elimination here. And I'm going to do what most people tend to do in these cases here. I'm going to eliminate the y variable. So I'm going to multiply, okay, I'm going to multiply that first equation through by 0.1. So I'm going to get 0.10x plus 0.10y, and 10% there of 2,000 is going to be 200. And then my second equation, I'm not going to make any changes to. It's going to be, that'll equal 190. And now I will subtract, and that's going to get me a coefficient of 0.02 in front of the x. The y's will disappear, and I'll be left with 10. So now 10 divided by 0.02 is going to be 500. Okay, now it's a very easy calculation for me to get the next one because I know that first equation. Y must equal, well, if x is 500, y must be 1500. Now, just to double check here, I'm going to just see if that works in my second equation. So I'm going to go to my calculator here and figure out 8% of 500, and I'm going to add to that 10% of 150. Oh, 1500. I was just going to say, I just looked at what I entered. It's like, that didn't work out at all. And there I do. As soon as I use the right number here, I do get 190 here. So that did work. Although for a moment it looked like I was going to have to redo this. Okay, so now I'm going to have to interpret this. So Nuri invested $500 at 8% and $1,500 at 10%. Okay, our next one here says Luis purchased a Métis flag whose length was 90 centimeters longer than its width. Okay, so there's a nice relationship right there. And it implies to me that I'm probably going to be looking for the length and the width. Okay, the perimeter of the flag is 540. Okay, now that is a total. Okay, what are the dimensions of the flag? So there we go. So what we've got here are number one is we're going to let, and we might as well use length and width here. We're going to let L be the length of the flag. And we're going to let W be the width of the flag. Okay, so I know that's what they want me to look for, so now I'm being very clear about it. Part two, I'm going to build the equation. Now, this first one here says the length was. Now remember, that word was implies an equal sign. Okay, whenever you see this, and I know I said it before, this state of being verb, is, was, are sort of thing, those are equal signs typically. So length was 90 centimeters longer, so I'm going to add that to the width. It's longer than the width, so I'm just comparing it. I'm going to add 90. Now right away I can see here that what I should probably be doing when I'm solving it is likely going to be substitution. I mean, that's a beautiful setup right there. Now the next thing that they tell me is that the perimeter of the flag was 540. Well, okay, let's think perimeter. Okay, the flag is going to be rectangular here. You're going to have width, L. So I know that 2 widths plus 2 L's is going to equal 540. So good. So now I've got two equations here, and that's the information I pulled out. Now, for my step 3, actually one of the first things I'm going to do with my step 3 is, just because I'm kind of lazy about this, like when I look at this, notice that in that second equation here, each one of those terms is even. So what I'm going to do to start off with here is I'm actually going to take this equation, I'm going to divide by 2, everything by 2. So I'm going to take the second one, and that's going to get me width plus length is going to equal 270. So I like that. It's just a little bit simpler for me to work with. Not that this would have been hard. Please don't misunderstand what I'm doing here. It's not that this would have been difficult for me to work with, but we want students to get into the habit of simplifying and making things easier for you as you go here. Because if you don't, it's more likely that you might get frustrated with what you're working in, and there's no reason to, okay? So let's not worry about that. Let's make it simple here. Now for my next step, I see that L can be rewritten as 90 plus W. So I'm going to do that. I'm going to rewrite that L as 90 plus W is equal to 270. So there's no coefficient here, so I can just drop those parentheses and put those like terms together. So 2W plus 90 is going to equal 270. So 2W is going to equal 180 when I bring that 90 over. And so I know, doing that quick division by 2 here, that W is going to equal 90. And then if W is equal to 90, jumping way over here, I can go back up to here, and I know that immediately that L must be 180. Now, let's just double check. Did I do that right? Okay. If I put those all together into this second equation here, does that get me 540? And when you think about it, 2 times 90, 180, 2 times 180 is going to be 270, 360. So put those together. Yeah, I'm going to get 540. So that works. So now we can answer the problem. Number 4, okay, the flag is, what's our width here? 90 centimeters by 180 centimeters. And there you go. Okay, this question right here, this alloy question, this one has got a, well, it's not a trick. I shouldn't say it's a trick because it's not. However, it's tricky. Okay. I remember when I was learning this, I remember that my teacher would draw these neat little pictures to kind of help us get through it and whatnot. But really, the issue to this amounts to just one term in here that's not immediately obvious and you got to think about. So I'm going to walk you through the exact same way that I've done this with everything else. We're going to start with well, we're going to work through the 4 steps here, and I'll just point your attention at the one spot that requires a little bit of extra attention, and hopefully that'll be okay. So it says here that the alloy is a mixture of metals. An artist was commissioned to make a 100-gram bracelet. Now right there, there's a total. Okay, a 100-gram bracelet with a 50% silver alloy. Okay, I'm not sure maybe at this point what that means, but he has a 60% silver alloy and a 35% silver alloy. Okay, so he's got these two things to work from. What is the mass of each? What is the mass of each? Probably supposed to say alloy there. Okay, so I'm going to mix these two up to get this one. And it's important that you can kind of get a visual on that. I am taking taking a certain amount of this mixed with a certain amount of this, and I am hoping to get this. So actually, this is giving me 2 totals. Not only is it giving me the total mass of the bracelet, it's also giving me a total amount of the silver in there. Okay, so now my step 1 here is going to be, and I don't really have any reason to choose one variable over another, so let's use x and y again. Let's let x be the mass of, I don't know, let's say 60% alloy. And we'll let y be the mass of the 35% alloy. Okay, so next I'm going to get to my equations, and here's where the issue is. Now, the first one is not so bad here because I know that whatever I grab of the 60% alloy and I'm going to mix it with the 35% alloy, my result has to be 100 grams. So that's easy. The first equation is x plus y is going to be equal to 100. Now, this is mass of alloy plus mass of alloy is equal to the total mass of the final alloy. But there's another aspect of this problem here. Okay, I'm giving you silver content. So essentially, I'm asking you to tell me also how much silver is going to be in this what is it, the bracelet here. Well, I know that however much I add of the x here, 60% of that is going to be silver. However much I add of the y, okay, the 35%, I know that 35% of that is going to be silver. Here is the spot that requires just a little bit more thinking on your part right there. Well, how much silver is there in the final? Because remember, this is total mass of one alloy plus total mass of the other alloy is equal to the total mass of the bracelet. Mass of the silver plus the mass of the silver is equal to the mass of the silver. Well, I know that I've got a bracelet that's 50% silver and 100 grams total. Well, if I put those together, I can tell you that there's 50 grams of silver in there. 50% of that 100 grams. That's the part that sometimes people don't get, that it's not given to you immediately what that number is, but I can put those two together to get it. Okay? Now, I can move on to solve this system. And like I said, that's the only part right there that actually requires a little bit of just pause, think about what we're setting up here. Silver content plus silver content is equal to silver content. Now, I can go through and get rid of kind of whatever variable I want. I probably are going to use elimination here because I've used substitution more frequently. So let's multiply the first equation through, let's say by 0.35. So 0.35x plus 0.35y is going to equal to, well, 0.35 times 100 is 35. This will be 0.60x plus 0.35y is going to equal 50. Okay, now, if I subtract those y terms are going to go away. And I'm going to get 0.35 minus 0.6 will equal negative 0.25x is equal to, and then 35 minus 50 is going to end up being negative 15. And so negative 15 now divided by negative 0.25, x is going to equal 60. And now this is pretty easy to put together here. I know that if x is equal to 60, because of this sum right here, I know that y must equal 40. Now, let's see if that works here. I'm just going to plug that 60 and 40 into this equation. So 0.6 times 60 plus 0.35 times 40. If I press enter, okay, I'm just working on the calculator off to the side here, and I do get 50. So I feel good that I did that right. And so now I just have to interpret this. We mixed, or the artist mixed, oh shoot, well it's not us, but you get the idea. Okay, we mixed 60 grams of the 60% alloy and 40 grams of the 35% alloy. Okay, and there we go. Okay, now the last question we're going to do is a money one. It says, Marcy has a total of 100 dimes and quarters. Now remember, and I get this question a lot here, dimes are 10 cents, quarters are 25 cents. We'll just throw that out there right at the beginning. So if the total value of the coins, okay, so here we go, we got a total. How many coins does she have? Now remember, that 100 there, that is also a total. It's the total number of dimes, quarters put together here. So how many of each, how many quarters does she have? That's all we're asking for right now. That's interesting. But we're still asking for the number of coins here. So what we're going to do is we're going to let's let D equal the number of dimes. I know I'm not asking for the number of dimes. I'm asking for the number of quarters, and we'll let Q equal that. But because we're dealing with a system of equations, I'm likely going to have to find two variables regardless. Or I'm sorry, I'm going to have to set it up with two variables. My equation, well, I know that the total number of coins is 100, so I know that D plus Q has to equal 100. And then I'm given a total value, so now I have to impose the value on here. So a dime is 10 cents, a quarter is 25 cents, and when I put those all together, I'm getting 14.05. Okay. Now, what do we do here? Well, I tell you what. Let's set this up using elimination. I'm going to multiply that first equation by 0.1. I'm going to get rid of the D because all I'm asked for is the quarter. So I don't need to find both variables. So I'm just going to get rid of the D here. So I'm going to make that 0.1D plus 0.10Q is going to equal 10. And then 0.10D plus 0.25Q is equal to 14.05. Okay. So now, when we subtract, because that's what I want to do to get rid of the D's here, I am going to get a negative 0.15Q, okay, and then I'm going to get 4.05 when I do that, actually, sorry, negative 4.05 when I do that subtraction. So 4.05 now divided by 0.15, I'm just going to do that on my calculator over here, and I feel good that worked out correctly because it worked out to be such a nice number. If I'd gotten a weird decimal there, I would have been a little bit less confident in that. Now, I do want to figure out, though, how many dimes I've got only as a check. Like, I can jump up here and say, okay, she has 27 quarters. Yeah, and I'm really confident that's true, but I'm not 100% until I go through and figure out, okay, if I look back up here at this relationship, that means she would have 73 dimes. Now let's just figure that out here. So 73 times 0.1 plus 27 times 0.25, as long as that equals 1405, and it does, then I know that I'm on the right track, that I got that correct. I feel very good about my answer. But anyway, and there you go. That's I think, a good set of examples on how to solve word problems using systems of equations. I'd really encourage you to go through those 4 steps. And remember that, like, the math portion here is only accounting for one step. There's a bunch of communication going on that's important the whole time. Thank you.